Okay, so this is a very short presentation, and it's a presentation on hunger and satiety. What influences the satiety and what drives our hunger, what makes us feel hungry, and what makes us feel full whenever we're eating. We have here almost 4 elements. So number one, whenever you are eating, remember the food it's getting into the digestive system. When it gets all the way to the duodenum, we usually have enteroendocrine glands, and these enteroendocrine glands, they make certain hormones whenever they receive elements of food. So one of the enteroendocrine gland that is usually released, we have this CCK, that is cholecystokinin. We have the GLP, peptide YY. All these are usually made whenever there is food reception in our gut, and they influence our eating. Then also, whenever you are eating, the food that we eat, it's usually converted, of course, into the glucose. It's also converted into amino acids, and this glucose has an effect in our eating because it influences our hypothalamus. Glucose, of course, also causes elevation of insulin, and then this insulin has effect, influences our eating. Then over time, if your eating is more than energy expenditure, of course, there'll be conversion of the excess into fats, and these fats or the adipocytes act as endocrine gland that releases hormones such as leptin, which influences our eating. So I want to start with the gut hormones. So whenever you are eating, the food reception at the duodenum causes synthesis of what? Cholecystokinin, GLP, neuropeptide YY. So this cholecystokinin, let me use cholecystokinin, has its receptor at the hypothalamus. Its receptor is cholecystokinin A. Remember, cholecystokinin B, it's usually locally. Cholecystokinin A, it's highly distributed at the neurons here, the hypothalamus. So the cholecystokinin A, you can also call it cholecystokinin 1. It's actually a G protein couple receptor, and whenever it's a GQ, whenever you activate it, you end up producing of course, there'll be phospholipase C, and the protein kinase C will be activated. And this activation, of course, leads to the gene expression of the neurons of the arcuate nucleus, and this will lead to the synthesis of what? POMC and CAT. This is pro-opiomelanocortin, and this is cocaine and amphetamine regulated transcripts. So if you have these two products here, they usually shut down the hunger drive while they activate the satiety center. So you stop eating. Remember, you stop eating, it's actually something that we do subconsciously because of these gut hormones. So that's all about gut hormone. Let me also talk about ghrelin, but ghrelin, it's the one, it will work, it activates the hunger drive. So whenever you're not eating, or you're fasting, or you're starving, there's elevation of what? Ghrelin. Then this ghrelin has its receptor. The receptor of ghrelin is growth hormone, secretagogue receptor. So whenever you have this, activation of this receptor, it usually causes the synthesis of this neuropeptide Y and the AGRP. So these two, they activate the hunger drive. So you go into a hunger drive, you eat it, they activate hyperphagia, and you end up eating. So that's how they activate. Remember, this has its own receptor again. I think it's Y1 and Y5 receptor. And the gouty receptor peptide, it has its receptor. I think it's melanocortin receptor 4. And whenever you activate the melanocortin receptor 4, you shut it. Of course, it end up leading to hyperphagia. So that I'm done with the gut hormone. Remember the gut hormones. Then whenever you are eating, that carbohydrate, it will be digested and converted into glucose. So the glucose in blood, what does the glucose in blood do? It has its glucostatic receptors here. They actually glued to, the glucose will enter into the neurons. And then once it gets into the neurons, what happens? It's metabolized to give ATP. But here's the catch. The ATP that is formed we have ATP sensitive potassium channels. ATP sensitive potassium channels. So the ATP sensitive channels will be closed whenever the ATP levels increases. And then whenever you close the potassium channel, the potassium cannot exit from this neuron, and this will have depolarization effect. And the neurons will start firing. Whenever these neurons in the aquat start firing, they switch off the hunger drive. And then they activate the satiety center, and you stop eating. So you stop eating, it's actually something that is done subconsciously. The glucose that is also formed, this glucose also causes the release of insulin. Of course, remember the very way it gets into the beta cells of the pancreas produces ATP, close the potassium channels of the beta cells. And then if you close the beta cells, there's depolarization. Depolarization will open it will open calcium channels. The calcium channels, these are the voltage gated calcium channels will open. Whenever calcium gets in, insulin is released, and then insulin gets into blood, into systemic circulation, and then we have the tyrosine kinase receptors of insulin at the hypothalamus. So whenever you activate the tyrosine kinase receptors, there will be synthesis of POMC, pro-opiomelanocortin, and this CAT, which is cocaine and amphetamine regulated transcripts. So these two, they usually shut down the hunger drive but activate the satiety centers, and then you'll stop eating. So that's over short term. And then remember, whenever you are taking too much of food than you're expending the energy, there'll be a deposit, there'll be too much fats. And these fats act as endocrine gland. They produce leptin. Then leptin has its own receptor, which is OBR. This is obese receptor within the hypothalamus. So whenever the leptin binds on the OBR, remember the OBR, it's Janus kinase JAK-STAT. It's a JAK-STAT receptor. So whenever it binds on the OBR, what happens? It also leads to the synthesis of POMC and CAT. Remember that is through the OBR, insulin is via the tyrosine kinase. So they work in similar way, but different pathways. This will lead to the synthesis of POMC and CAT. We've said this to shut down the hunger drive, but activate the satiety center. So over time, if you have too much fat in your body, it reduces your eating. And it's usually said that if someone has, let's say, the OBR becomes insensitive, then it means those who are obese, who are morbidly obese, their OBR, it's usually, they have dysfunctional OBR. So because the leptin, yes, it's being produced, but the OBR are dysfunctional. So what does that mean? It doesn't reduce eating. The leptin doesn't reduce eating that's supposed to reduce, and you'll have too much eating, and this will lead to morbid obesity. So that's all about what I wanted to present. I've done it in less than 10 minutes, but remember the gut hormones, CCK and GLP, leading to production of PMC and CAT. Remember glucose with the glucose excited neurons, shutting down eating. Fats are deposit leading to production of leptin that work through the OBR. And hunger, we have ghrelin that work through the growth hormones, secretagogue receptor, leading to production of neuropeptide Y and their gout receptor peptide. Thank you so much. That is the end of my presentation.